Hello, and welcome to the Fundamentals of Graphing and Slope. This is an intermediate algebra video. You can watch it if you're in other algebra classes as well, but it's designed for the intermediate algebra student. So, we're going to graph the equations by creating a table of values and plotting points. We have y equals 2x minus 6. So my table of values, x is my independent variable, and I'm going to write the full y equals 2x minus 6 over here. That'll tell us exactly how we get our values. So let's take my 5 favorite x values. I know, it's weird for somebody to have favorite x values. But I do. I don't have a favorite color or favorite number, but I have favorite x values. That's how I roll. Alright, so we have y equals 2 times our negative 2 minus 6 each time. We will use this same pattern, the same function, the same skeleton in order to evaluate and find the y coordinate of our points. All right. And each time the input value, the x, changes slightly, but it's all the same over and over and over again. So we'll have 2 times negative 2 is negative 4. Negative 4 minus 6 is negative 10. This gives us a point, negative 2, negative 10. Negative 2, negative 10. All right. 2 times negative 1 is negative 2, minus 6 is negative 8. Negative 1, negative 8. 5, 10. 9, 8. Here we are. 2 times 0 is 0, minus 6. 2 times 1 is 2, minus 6. 2 times 2 is 4, 4 minus 6. There we go. We have 0, negative 6. We have 1, negative 4. And we have 2, negative 2. Notice that all of these appear to be on a line. Of course, I will never be able to draw a line even as crooked as my points are. There we go. Boom. Close enough is good enough. If you ever miss a dot, you just make it a little bit bigger and it all works out. So we could list all of these points. All right, 0, negative 6. If you would like to see them written out, make sure your 2 doesn't turn into a 7. And we can graph the equation. We could do this again for a different type of equation. Suppose we have our x, our y is x squared minus 8. I'm going to take my same favorite x values. It's not a 5 though, it's a 2. Minus 2, minus 1, 0, 1, and 2. My y value will be found by squaring my x and subtracting 8 each time. So I like to set up this form because once I get to evaluating, it's easy to get mixed up and forget what it is that I'm supposed to be doing at each step. So if I write down this form, I'm less likely to make a mistake. So now I can see everywhere I have an empty set of parentheses, it used to be an x. Here's the x that goes inside. And what do I have? I have negative 2 squared, which is 4. Negative 2 times negative 2 is 4. 4 minus 8 is negative 4. So at negative 2, I'm at negative 4. Negative 1 squared, that's negative 1 times negative 1, which is 1. 1 minus 8 is negative 7. Negative 1, negative 7, that's 5, 6, 7. There we go. 0 squared is 0. 0 minus 8 is negative 8. 1 squared minus 8, that's 1 minus 8, that's negative 7. 2 squared is 4. 4 minus 8 is a negative 4. Notice how these values repeat. Let's take a look. Negative 8, negative 7, and negative 4. Now, in order to draw this graph, my hand-eye coordination needs to be a little bit better than it is. Oh, that's not bad. I'll take that one. a little shaky here, but you know, if I try to make it better, it'll look worse. A little crazy here as well. But close enough is good enough. Close enough is good enough. We're sketching. We're not creating art here. And so we could use a table of values in order to determine the shape of our graph. All right, so let's look at some equations that we already have discussed if you watched the earlier videos. An equation for the total cost C in dollars for purchasing L lunch coolers is C equals 45 plus 3L. We want to create a table of points that satisfy this equation. Now, when we're thinking about this, so we'll have our input L and our output C. All right, each time our input is L. Are we going to have a negative number of lunch coolers? No. I would say 0 is the smallest, and then I might just, I don't know, maybe I'll do 10 and then 20. Maybe I'll throw in a 30. Let's see. Now I'm not writing the equation, but each time, if you would like to write it down, each time I'm putting in my L inside these open parentheses. So 3 times 0 is 0, plus 45. 3 times 10 is 30. 30 plus 45 is 75. 3 times 20 is 60. 60 plus 45 is 105. And 3 times 30 is 90. 90 plus 45 is 135. And we could keep going, all right? We could go as high as we want to. And I didn't use 1, 2, 3. I used 10, 20, 30 because of the type of problem it is. If it's a generic function like the first two, I'll use simple numbers like -2 to +2. If it's a real world problem, I'm going to think about what the real world possibilities are. So in order to graph this, I'm only going to focus on positive L values. So let's make this 40, 20, 30, and 10. And what are my costs? Let's see, let's go maybe 25, 50, 75, 100, 125, 150, and these will be costs in dollars, and this will be L lunch coolers. It's always a good idea to label your graph with units. So what do the 10, 20, and 30 represent? They represent the number of lunch coolers. What does the 25, 50, 75 represent? It represents the cost in dollars. This tells your reader, whoever's looking at your work, what it is that you're discussing here. All right, so 0 is 45. So we'll go about right there. 10 is 75. Oh, that's a good number. 20 is 105. So about right there. 30 is 135. That's a little bit above 125. I don't know, about there. And we can see that for the most part, these do follow a nice straight line. Keep in mind I don't have the grid on here, so definitely when you're sketching graphs by hand, close enough is good enough. All right, but we can now find a graph of generic functions as well. All right, so let's talk about these lines. 2 out of the 3 graphs we just drew were lines. So let's focus in on some key concepts of lines. Slope, the ratio of vertical change and horizontal change of a line. Always vertical to horizontal. The increase or decrease in y for a unit change in x. So this is super important. Got to the edge of my board here. The increase or decrease in y for a unit change in x. That's super important. For a line going through 2 distinct points, x1, y1, and x2, y2, don't let those subscripts fool you. It's just the first x and the first y, second x and the second y. The slope, frequently called rise over run. I don't get that, but whatever. I don't know. Rise over run. I mean, I do get it, but I don't like it. Change in y over change in x, and this is the difference in y values divided by the difference in x values. Keep in mind that fractions have a numerator and a denominator, Or maybe your fractions have a top and bottom. I had a friend tell me one time, bikinis have tops and bottoms, fractions have numerators and denominators. But you know, we all remember things as we remember them. But look, either way, in top bottom, bottom comes first alphabetically. In numerator denominator, denominator comes first alphabetically. In x and y, x comes first alphabetically. So however you remember the names of fraction parts, whatever comes first alphabetically, that's going to help you remember where the x is. X comes before y. So one of the biggest issues with slope is getting this upside down. So that's the way I remember it. Slope also represents the amount the output variable is changing for every unit change in the input value, and we'll be using this as well. All right, so the two things that I've underlined say the exact same thing, and we're going to be using them as we write equations later on. All right, so let's use the graph to find the slope of the line. So I'm going to find any two good points. Here's a good point, and here's a good point. So I can see that the y value, we go up 1, and then we will go to the right 2. So our slope, up 1, to the right 2. But keep in mind, I could have chosen this point and this point. And so I'll go up 2 and to the right 4. Let's make it a proper 4. But 2/4 simplifies to 1/2. So it doesn't matter which 2 points you choose, because it's a straight line, a line. And any line that is straight is just called a line. If it's not straight, it's called a curve. It doesn't matter which 2 points you choose. So we don't have to do this twice in this other problem. Here we have a point, 0, 2. And the next time I see it cross the grid line really well is down here at 4, -1. So my y value went down 1, 2, 3, and my x value went to the right 4. So my slope is -3/4. So I like to, you could choose a point like this if you want, but then you have to estimate. So I like to use good grid crossing points on problems like this. So always look for those good ones. But it's not just with graphs. We could actually use tables to find the slopes of a line as well. In order to find the slope of a line, we're going to subtract. And in order to subtract, I want to make sure this is definitely going to be linear. This tells me it's a line, so I'm going to assume it's correctly aligned, but let's see. Let's use point 1 and point 2. So I'm going to subtract the y values, y2 minus y1 all over x2 minus x1. And this is -16.5 minus 24 to give us a -40.5. -1 minus a -4 minus a negative, so it's -1 plus 4, which is a 3. If I divide my answer by 3, I'll get a -13.5. Now, because the 0.5 is a terminating decimal, right, it's just 0.5, done. But we can leave it in decimal form. If this were -13.33333, then we would write it as a fraction instead. That 3 is looking ugly. But then I wonder, like, what if I pick the wrong points? Maybe I'll use this as 0.1, and oh no, that has halves in it. And this is 0.2. What's the difference? Let me see. y2 minus y1 over x2 minus x1. -1.5 plus 16.5 is a +15. 5 minus a -1, so that's 5 plus 1, that's 15/6. Did I do this right? -1.5 minus a -16.5 is indeed 15. 5 minus a -1 is indeed 6. and I get 2.5. I see what the problem is. See, this bothers me. I should get the same slope no matter which values I use, but here I see I forgot the negative. I hate it when I do that midway through a video. The negative 24, so this is minus a negative, it'll be plus. So this 40 is not correct at all. It'll actually end up being positive. What do we have? We have negative 16.5 minus a negative 24. Negative signs are super important. That is 7.5 divided by 3. And if we take 7.5 and we divide it by 3, we will end up with the 2.5 that we thought we should have. So that was my point originally, is that it doesn't matter which 2 points you choose. If it says it's a line, they should have the same slope regardless. But it's also a good way to find mistakes in case you make a mistake by forgetting a negative sign. All right, moving past that. Now it says determine whether the table gives all points on a line. So I want to find out if the slope is consistent. So I'm going to take these two. I don't know why I put that 18.5 in there. 18.5 minus 11 all over 12 minus 6. 18.5 minus 11 feels like 7.5 over 6. So 7.5 I happen to already have on my calculator. Let's divide that by 6 and we'll have 1.25. Let's take another pair of points. Let's take these 2 points and find their slope. Now, because it says determine, we check our arithmetic because they may or may not match up here. Let's find out. M equals 31 minus 16 over 22 minus 10. 31 minus 16 is 15. 22 minus 10 is 12. That is 1.25. Yes. All on a line. Because this slope is consistent, it's the same value each time, we know that these points will be on the line. The chances for it to not be when these two don't is rare. So let's see here. Let's do the same thing. Let's take these two. Our slope is 2.8 minus 3.4. Subtract the y values in the same order. Subtract the x values. 4 minus 2. 2.8 minus 3.4. If I was in the classroom right now, I would absolutely do that part in my head, but since I'm doing this on video, I want to make sure my numbers are right, especially after that error up here. Negative 0.6 divided by 2 is a negative 0.3. All right. And what if we check these two? Subtract the y values, 1 minus 5.4. Subtract the x values, 8 minus a negative 3. 1 minus 5.4. Negative 4.4. 8 minus a negative 3. That's going to be 8 plus 3. That's 11. That is something I want to check. Let's see. 1 minus 5.4. Fantastic. If we divide that by the 11 that I'm pretty sure about, I do get no 0, just a 0.4. I knew that. You knew that too. You were probably screaming at me the whole time. Tuesday, no. All right, there we go. Make the decimal bigger. It looks like it matters. So these are not all on a line. And if you're like me and sometimes you doubt yourself, just go back over this, make sure you did it correctly. Go back over the blue one, make sure you did it correctly. If they're both correct, then your answer is fine. It's fantastic. I am going to stop this video here. I'm going to turn this into a 2-part video. It's getting a little out of hand now. So that's the end of part 1.